You're gonna miss it.
No.
So on Friday, what you guys are going to do is you're going to explore this last type of graph. It's called a box plot. And I think you guys at some point in middle school did a box plot. We lost somebody. It's also called a box and whisker plot. Have you ever seen something that's called a box and whisker plot? A lot of times, oops. A lot of times, the whiskers out here at the end, they have like a little whisker like this. And so like these two are the whiskers, and then this is your box right here. And that's why it's called a box and whisker plot. I know, Michael, you did it last year in your class. And did y'all do something like this in middle school? The importance of box and whisker plots and really these types of data is it shows our 5-number summary. Hold on. These 5 numbers break up our data into 4 quartiles. What's a quartile? What percentage is a quartile?
A quarter.
A quarter. What percentage is that?
25.
25%. So what a box and whisker plot does is it breaks up. Getting ahead of myself here. But it breaks up the data into 4 quartiles. You already know about the minimum, the maximum, and the median. But I'm going to show you guys 2 new numbers: the quartile 1, which is Q1, and quartile 3, which is Q3. The cool thing about the box plots is that it's always going to break up data based on how much quartiles it is, and every quartile is always going to be even if it doesn't look like that. So watch this. This whisker out here, this whisker right here is the top 25% of all the data. This box right here is the top 25% of all the data. Notice how median is cutting it in half. We know that 25 and 25, that's half of it. Below the median, same thing. This is the second 25%, and then this is the first 25%. Why are they all not the same size? Because it just depends on how far spread out the data is. The top 25% of the data is a little bit more spread out than the bottom half of the bottom 25% of the data. Okay, the middle 50% falls between quartile 1 and quartile 3. Okay, you guys already know about the range. That was a measure of spread I talked to you guys about before lunch, where you take the maximum and subtract the minimum. The last thing that you want to know about is called the interquartile range. The interquartile range is if I take Q3 and I subtract Q1. Okay, so there's a little bit different range there. Well, give me just a few minutes. All right, I'm going to show you how to create a box plot, so you know how to do it on Friday. You're gonna do it on the computer again. So it's but you need to know where these numbers come from. How do I find the 5-number summary? I'm gonna do this with baseball. You know who Roger Maris is? Roger Maris, old school baseball player, long time ago. He had several seasons hitting home runs, and his best season of hitting home runs was 61 home runs in a season. He held that record for 50, 60 years until the late 90s, and somebody on steroids broke his record. We won't talk about that. Okay, but Roger Maris had the single season home run record. 1 year he had 61 home runs. These are all his other years of playing baseball, and I just put them in order already from least to greatest. What do you notice about the rest of his years?
Started going down slowly.
Well, then nothing really came close to his 61, right? And nothing really came close to that. If I were to ask you to find these 5 numbers, I bet you could find at least 3 of them for me. What's the minimum season? 8. What's the maximum season? 61. And can you can you see what the median is?
24. No, 20. I'd say 24.
Somewhere in there, right? Yeah, it's in between those 2 numbers because there's an even number of numbers. So what do we do again to figure out the median?
We'll find the middle between that. So it's like
we find the middle in between these. So we average these out, add them together, divide by 2, and you get 24.5. Okay. So here's the 2 new numbers. You already knew about those numbers. Here's the 2 new numbers you don't know about. Q1. Q1 is actually the median of the first half of numbers. What's the median of the first half of numbers? 14. Easy. You can see that pretty quickly, right? So that's our Q1. Now Q3 is our median of our second half of numbers. What's the Q3? 33. It's all right. So there's our Q3. These 5 numbers are all the 5 numbers you need to know in order to make a box plot. Pretty easy, right? In order to kind of show you this a little bit more, I'm also going to do another person. Have you heard of Babe Ruth? Have you seen The Sandlot? You guys have seen The Sandlot, right? Sandlot. Somebody last period said they haven't seen The Sandlot. I'm like, what? How have you not seen The Sandlot? I'm not going to call him out. All right. Look at Babe Ruth's seasons. He played more seasons. But he never broke that record either. His best season was only 60 home runs. But he also had played a lot more. What's the minimum for Babe Ruth? 22. What's the maximum? Can you eyeball one and see what the median is?
46.
Which 46 is it? The first, second, or third? The one in the middle. Yeah. So there is an exact middle for that one too. That one's pretty easy. What's Q1?
35.
35. What's Q3? 54. You can see it. It's pretty easy to eyeball when there's not very many numbers. Now, when you have a lot of numbers, let the calculator computer do it for you. But this is I just wanted to show you how it's done. All right. Last slide. I'm going to show you how to make a box plot. We're going to take these numbers, and these are the only numbers we need to know in order to make that box plot. We do need a blank graph. And this time, unlike the histogram, I don't need anything on the y-axis. The y-axis doesn't actually matter. It's just the x-axis. I picked it increments of 5 just because it's nice and easy numbers, and then I'm going to go from there. We're going to do Roger Maris first. Now, Roger, all I need to know is those 5 numbers of the 5-number summary. The minimum, the Q1, the median, the Q3, and the maximum. And I'm going to make 5 little hash marks on each one of those numbers. So his minimum was right there. His median, or Q1 was there. There's his median, his Q3, and his maximum. What do you think I'm going to do next? Fill in the box. So I'm going to connect a line right here between Q1 and Q3, and from Q1 to Q3 there to create my box. And then I can connect my whiskers here on both sides. And this is a box plot that shows the 5 number summary. I can actually see, and I know this is the minimum, this is Q1, this is the median, this is Q3, and here's the maximum. Before we do Babe Ruth, tell me some things. Remind me too as well. What percentage falls in this first whisker? Still 25%. It's 25% here, 25% of his seasons, I should say. 25% of his seasons right here, and 25% of his seasons right over here. Why do you think this whisker looks so big? Yeah, it could possibly be an outlier. I'm actually not going to go over that today with you guys, but that's good, Danielle. I'll do that next week. We'll see outliers a lot better with box plots. That's why I like box plots. Yeah, I mean, he had that one good season way over here on the right, and then the rest of his seasons were like, they were all right. They're nothing special. So it kind of looks that way. If I asked you the shape of this graph, what is the shape? It's skewed to the right, right? This one's definitely skewed to the right, and we know it's skewed right because the tail's on the right side, right? So we know that. Good. Let's compare that to Babe Ruth, though. And the comparison, when we put Babe Ruth up there, you'll definitely see why Babe Ruth is a better baseball player. Look at his minimum, Q1, median, his Q3, and his maximum. And I'm going to go ahead and close in the box and attach the whiskers. Now, we know that Babe Ruth didn't have the best season. Roger definitely had the better season at that one time. But can you tell who the better ball player is? It's pretty easy to see that Babe Ruth overall had way better career. Look at this. His Q1 was even higher than Roger Maris's Q3. That means that Babe Ruth, 75%, because this is all 75% right here. It's just not that 25%. 75% of Babe Ruth's seasons were better than the top 25% of Roger Maris's seasons. And that's a pretty distinct thing to see. How would you describe the shape of Babe Ruth's box plot? Is it as skewed left as this one is skewed right? No. So could we add something in front of skewed left? Maybe like slightly skewed left. Yeah. Somewhat skewed left. That's a good word too, Juan. Definitely don't just say skewed left on that one unless it's really skewed left, right? And I like to use adjectives all the time. You also know where the center is, obviously, here too. Here's the one drawback of box plots. Can we tell any unusual features? Can we tell any gaps or outliers? No, not right now. Now, next week, I'll show you guys what it looks like when we can see an outlier, but you still can't see gaps in these. Okay? Still can't see gaps in these. So that's how you make a box plot. That's how you read a box plot. And on Friday, I'll leave you guys with something a little bit shorter for you to just answer some questions, understanding and reading box plots. I may or may not even have you make them yet. I may make you one on a website, just like it'll be a different website though than that histogram one.